Before we explore image processing and computer vision capabilities, it's important to understand how computers interpret images. Unlike humans who recognize objects, colors, and patterns visually, computers process images as numerical data. In this lesson, we'll break down how images are represented in AI, how colors are stored, and how filters help in image processing. So what is images as a pixels array? At its core, an image is simply a collection of pixels. There are tiny dots that make up the picture. Each pixel has a numeric value, and these values are from a grid or an array that represents the image. For example, let's consider a grayscale image, where each pixel has a brightness value between 0, which is black, and 255, which is white. Here is a 7 by 7 grayscale image. This array represents a 7 by 7 image resolution, meaning there are 7 rows and 7 columns of pixels. The higher the resolution, the more detail an image contains. Looking at this matrix, the white pixels, 255 values, form a small square in the center, while the rest remain black, which is zeros. When they display on this screen, we can see image with a bright shape in the middle. So how color images and RGB channels work? Most digital images are not just grayscale. They contain color. To represent color images, we use RGB or red, green, blue model, where each pixel has 3 separate values, one of each color channel. Here is how we represent the same 7 by 7 image in color. This is the red channel, and that's the green channel, and then lastly the blue channel. So by combining these 3 layers, the computer forms a color image. For example, the purple pixel are created using red, which is 150, green 0, and blue 255. The yellow pixel in the center are created using red, which is 255, green 255, and blue, which is 0. By adjusting these values, we can generate millions of colors. So how to use filters to process images? One of the most important techniques in image processing is filtering, where we modify an image by applying mathematical transformations to its pixels values. A filter is defined by an array called a filter kernel, which is applied to an image to create effective such as sharpening, blurring, and edge detection. For example, here is the 3x3 filter kernel used for edge detection. So how does this work? The filter moves across the image, multiplying each pixel by corresponding value in the kernel, then summing the results. Let's apply this to a grayscale image. Step 1, apply kernel to the first batch. And then the result is going to be -255 is stored in a new array. Then on step 2, we move kernel to the next batch. Now, the new array contains values like -255, -510, and so on. Since pixel values must be between 0 and 255, we adjust them accordingly. The effect, which is going to be the edges of objects, are highlighted, making it easier for AI to recognize shapes. This type of filtering is called convolutional filtering. It is widely used in computer visions, especially in convolutional neural networks or CNNs, for object detections and image recognition. So computers see images as pixels array, either grayscale or RGB. Filters modify images by changing pixel values, allowing AI to detect edges, sharpen, or blur an image. Convolutional filtering is the foundation of modern computer vision applications, include facial recognition and object detection.